Okay, welcome back to the final session that I have today. And we're still in the 2018 paper. I can get this going. Okay, we're going to do example 6, I think, of the 2018 paper. Off the bat, it's 20 marks. So if you can smash it out of the park, you're on your way to a good pass. And a second thing that I want to say is when you see this question or something similar to it, don't be intimidated by the graph and all the lines. It's really easy. And every question they ask you, subsequent questions on that, build on that. So they really guide you through it. Cool? So let's get cracking. What we're given is we're given a function. We're given it in its entirety, f of x. That's a nice parabola. We're given the coordinates of where this function f and another function g cross. And we're also given the coordinates of this function g on the x equals 0, or where it crosses the y-axis. Let's say that. Okay, so it crosses the y-axis at x equals 0 and y equals 1. That's also given. And then we're given on the left-hand side here some extra line mn. That's meant to intimidate you, but you're not going to be intimidated. Okay, so we know that they constantly guide us through it, so we just need to work through it step by step. The first question is easy. So they're saying show that the function gx equals a certain thing. So they're giving it already. Does it make sense? Well, yes, because this gx is a straight line. If I write down the general equation of a straight line, mx plus c. That m is the slope of the line, okay? And the c is where it crosses the y-axis. So I'm already given that value in the beginning. That equals 1, right? So this part here we've already checked, and it's correct. So the only other thing we need to double check is the slope. Cool? Well, we know that a slope by definition is delta x, well, delta y divided by delta x. Okay, if I draw that in, I know that the slope, well, I'm going to try and do this neatly. The slope of this line is equal to the change on the y-axis divided by the change on the x-axis, right? Now we're lucky. We're given 2 points. We're given this point C, and we're given this point 1, 0, 1, shall I say. So we're already given the values. All we need to do is plug them in. Well, at this point C, we have a value of 5 and an x value of 4. And where it crosses the y-axis, we have a value of 1 and an x value of 0. That's 4 divided by 4. That's 1. So this equation gx, that's cool. We've proven the y-axis. We've checked that. And we've proven here in this section the slope. Cool? 2 marks. Then we're asked to calculate the coordinates of A and B. Well, these are special points, right? They're nothing else than where this parabola crosses, intersects with the x-axis. Okay, so these, in essence, we're asked to calculate the roots of the parabola. So let's do that. We know x squared, that's an x by the way, minus 2x minus 3. To calculate the roots, we have to equal this equation to 0. And then we have to factorize. It's over on the left. Get an x there and an x there. Okay. We know that the factors of 3, well, we can multiply 3 by 1. Then we get 3. Okay. So I'm going to put in here a 3 and a 1. Cool. I need to get a minus 2. Okay, so one possibility is to put a minus, because I also have a minus 3. So I'm going to have a minus 3 here. And let's see, a plus 1 there. Let's double check this quickly. X squared minus 3x plus 1x and minus 3. So these two equate to minus 2x. Is that fine? Yes. So there is factorized equation. Okay. And so x equals minus 1. Okay. Or x equals 3. Cool. Final step. A is where the x is minus, so the coordinates of A is minus 1 and y is 0. And the coordinates of B is where x is positive, so that's 3 and 0. Cool? Hope this is right. Looks okay. But that's easy, right? So you're inspecting the graph, you're seeing, oh, these A and B, those are special points. They're merely the roots of this parabola. And we factorize the equation. And we just, final step here is to write actually the coordinates, right? So, next question. Okay, we're again asked the range of this function f. And in the previous video, we dealt with the domain. And we saw that the domain had to do with the input values, or what I also called the independent variables, right? Okay. And what they define this as here is the range is the set of possible output values, which I also refer to as the dependent variables, okay? So it's all the values where this function fx, which is the dependent variable, all the values where this would, all the y values where this would be a legitimate function. Okay, already by inspection we can see, well, all these values, because there's these two arrows here, so all positive infinite values count, right? But there's this turning point here that we need to calculate. Okay, so the domain or the range of this function f would be any value that is on this y-axis here and larger, okay? But the important thing now is to find the corresponding y value that's related to this turning point. Okay, so we first need to calculate that coordinate. How are we going to do that? Well, that's a special attribute of the parabola also, right? And I hope you agree with me that we will have to do a first derivative. We have to calculate the first derivative, right? So, first derivative of this function f, if I write that out more concretely, it's the derivative of function f derived with regards to the independent variable x. Cool? Well, that's easy. That'll be 2x minus 2. Okay? Go and check that. It's very simple. Okay. To find this turning point, well, that's where this tangent line at that point has a slope of 0. Okay, important that you realize that. So we've calculated the derivative. The derivative is nothing else than a tangent line. And at this turning point, that's where the tangent line has a slope of 0. So we can equate it to 0. Okay. Having done that, I can compute the value of x because this is unknown. Remember, this point here has a x coordinate and a y coordinate, and we have to compute both. So we're first computing the x coordinate. We have 2x equals 2, so we have x equals 1. Okay, so we've done this part here. You can fill that in, and now we need to find the y value still. Okay, how do we do that? Well, we're just going to plug this value of x1 into this function f, and then we get a corresponding to that y value. Okay, so f and the point 1 equals, well, we have 1 squared is 1, minus 2 times 1 is 2, minus 3, that is minus 4. Okay, so the coordinate here is minus 4. Does that make sense? Double check that quickly. Well, this point lies in the positive x-plane and in the negative y-axis. So that those values do make sense. Okay? So the answer to the question then is the range of f. Well, that is for all the values of y, including minus 4 to infinity, because of these arrows. The convention is always to write not including. Okay, so that's the answer to this question.